Hello everyone. In this session, we will try to understand what exactly the system calls are. So in earlier session, we talked about interrupts, we talked about trap. Now let us understand how exactly system calls are handled in Linux operating system. Now to know like what kind of system calls are there, we need to know about few of the commands. So let us try them. So first command that we are going to try is man. So I'm writing man to seek information. Man means manual. I want to see manuals in help. So a manual in Linux is actually can be seen with these different 9 sections. Now while you try to make use of man, sometimes the help may not be provided to you. Okay, so let us say suppose if I write man printf. Now this printf is meant for the user command. Fine. Which is not the printf that we are expecting from C language. If at all I have to see what exactly kind of help provided for printf function in C language, now writing just man printf will not work for me. So to do so, let us understand or let us make use of the section properly. So the proper section to get information about printf function is this section number 3. So section number 1, like which it was showing earlier, it is meant for shell commands or executable programs. Now, if at all say I have to see now syntax of printf, I will write like this. Right. Now, if you see, it is not showing me the manual. So what exactly I should do now? So if I am not able to see this, then I will write try for 3 because I was trying for 2, it was not working. So let me try for 3. Now it is showing me this because section number 2 was meant for system calls and section number 3 is meant for library functions. Now suppose while you write man 3 printf and if you still see this kind of stuff or some other error, then you have to do one thing. So let me show you what the command you are going to make use of. So you have to use this command sudo apt install man pages dash dev man pages dash POSIX and man pages dash POSIX.dev. So once it installs these, like once you install these, then you would be able to see remaining, what you can say, the manuals or help of the functions. Second command that I'm going to make use of to introduce to you this system calls rather is strace. Now this strace is meant for tracing the system calls and signals. Now this helps us to know how exactly the system calls can be used or what exactly the system calls are used by your executable. So let us talk about say one executable. Let me take example. Now let me execute this command. So ls-ltr. So let us say my code is this print my name.c. Okay. Now what I will do is I will edit this code and I will write a printf function, okay, which will print just my name. So let me comment this all because I am interested into printing my name. So let me write printf and my name. So then party. Fine. Now let me save this and let me compile this code. Like I'm using I instruction set architecture of 32-bit Intel. Fine. So that's why f-m32 print my name.c. Okay, I made a mistake in the code, so let us correct that error. Now let us compile again. So now we got executable. So if I execute, you will find that as we use printf function, so it printed this. Now definitely question comes into mind. If there are hundreds of programming languages, how Ubuntu kind of operating system would be responding to it? Because for C we are having printf, for Java there would be some print statement, for Python there would be some print statement. Now if there are multiple languages, now how your processor, how your architecture is responding to that, or even how your operating system is responding to that. because with the architecture, operating system is the mediator, and we want to print this on the output screen, like what we see here. Now, how exactly it came to know that it should print it on the screen? Now, if I use printf, we know that printf function prints on the screen. Now, why it hasn't asked me like where exactly you want to print? That means what? Printf is developed in such a way that printf should print on this output device only. Now, who communicates this? So let us try to use a strace command, which I showed you before a while. What exactly it is doing internally. So when I write strace dot slash a dot out, let us try to understand and let us try to concentrate on this string, the name that we used. So let me print this. So you will find that there is a write system call, and this is like if I see all these lines that are displayed here, all these lines contain something, and after every name there is opening bracket. Okay, on almost all the lines, brk opening bracket, arc opening bracket, then mmap2 access, everywhere I am seeing that there is opening bracket. Okay, now these all are called as system calls. This is the mechanism like that we earlier understood about the interrupts and system calls. Now, while I go below, I can see that there is a string printed with my name Nitin Patil. Now to print it, it used this string. Now if I count the number of characters there, so these 5 plus these 5 and space, so totally 11 characters. So 11 characters are printed. Now how this is communicated? So write is containing here 1, and this 1 actually means the standard output device. Now how exactly we came to know that this one is standard output device? So let us first understand syntax of write. So let me write man to write, because this is a system call and we used a strace. Okay, so if I write say man strace, you will be able to understand what this strace means. Strace is meant for tracing the system calls and signals. Okay, so if I write man to write, because if I write just man write, then it will display it from the shell or user command, and we are interested into the system call. That's why we have to write man to strace. Correct? Sorry, man to write. Now this is a write function. Now if you see, it is returning a size t, writes up to number of bytes, count bytes. What are the count that you specify as a third parameter? Those many bytes would be printed from the buffer. Buffer means the string that you are passing to the file referred to by the file descriptor. So this is file descriptor. So file descriptor here, which was used for our executable, is 1. Now this 1 probably may be leading to what you can call it as the standard output device, but somewhere this should be mentioned. Now where exactly I can find this kind of data? So let us search for the machine. So as I am using Ubuntu operating system. Now there might be some modification into the directories that are used internally by the system. So depending upon which distribution you are using. So /usr/include. Then let me write this x86. Sometimes on few of the machines you should see directly ASM directory. Now here I am going to make use of this, and then I will write ASM. Then let me write unistd.h, and this file is containing the details. Now this is telling me that these are the two kinds of files that would be available: 32-bit, 64-bit, and so on. And so let me go back one more directory back to the parent directory, and let me write this. And now if you see, let us go back again and let us write unistd.h. Now this is file containing most of the symbolic constants that are used by POSIX standard. Correct? So if I go below and if I try to find the numbers, okay, these all are the constant values that are used. So we are more interested into file descriptors, correct? Like what was shown to there, like the first parameter integer fd. So let us go below and let us find this. So these are the 3 standard descriptors that are available. So standard file descriptors are std input, it is 0, std output is 1, and standard error is 2. Now we are focusing currently now onto the standard output device only. So standard output device is mint for 1. So what are the number of bytes that you added there in the code? Okay, so as I stated that we included a 15. So this, sorry, 11, 5 plus 5, 10 plus 1, 11. So if I make the change in my code, then you should be able to see. So let me write cd tilde and let us write Emacs cd omca Emacs print my name. Next, let us go to this. Now we saw about the standard output device where it printed. Now let me show you. I'm uncommenting this. So what happens? Suppose if I want to read input from the user. So we know that it would be reading input from the standard input device. So let us try to understand again what exactly it means. So I'm uncommented the code which was commented by me earlier. Correct. So I'm having one putS and two printfs and one scanf. So read write system call should be there, like let us say 1 2 3. Put is again a printf kind of stuff. Printf, putS are from same category. So all these three would be having write system call, and scanf should have now what you can call it as a read system call. So let us go back, save this, and compile. Now if I try to execute this code, you will see it is expecting a number. So I inputted a number. Now you should see like it used enter a number, then it used the 34, and then it printed this, and then our name is printed. So now if I write strace and if I write dot slash a dot out. Now let us go below, and you should now see the things like it is printing enter a number slash n. So if I count these numbers 5 space 6 7 8 9 10 11 12 13 14 15 16. So 16 is the size that is printed. Now read, it is expecting some input from me. Now let us give input here, say 5 6 7. So I gave three values. So now let us try to talk about this read. So read, while I inputted 5 6 7, I pressed enter key. So 5 6 7 are the, though it is a number 567, but it took it as a character, and that's why 567 plus slash n, it took 4. And you can see like this is what is printed there now, and this is how exactly the system calls are. Now if I again go back and try to see this, so with read the first argument is 0, so I gave 34. Now if I talk about write, it is containing 1. So if you recall, less slash usr slash include slash exec exec 6 asm. Sorry, here you should see this in include unistd.h. So with 0, you should see standard input device. Correct. Now let us try to understand what is read input device. Okay. Now this is the number that I have. Standard input file number to be 0. So now this is clear. So ultimately there are different system calls. Now where can I find these all system calls? Like how exactly the system calls are known by the operating system. So if I have to find list of those all system call numbers, then I have to go to this directory exec6, then asm, okay, and then just write unistd underscore 32.h. This should contain all system calls for 32-bit Ubuntu operating system. So you can see like our write can be found here, read is here, write is here, exit, fork, all these system calls are added for every service which is provided by operating system for you as a user. Correct. So let us see how many of them are there. So if I go below, then you should be able to see now all these system calls written. So there is 448. So this is for 32-bit numbers. Correct. So if I go up, if I go display it again, you can see the numbering starts from 0. Correct. Now if I want to display 64-bit ones, so you write 64 here. You should see now, so again starting from 0. Now if I go below, again probably same number of system call numbers are 448, 0 to 448. So you can see same number of things are there. Correct. So these are the system calls that are added by the system.